Okay, so in practice, how do we actually expand terms using the binomial theorem? Well, this is how it's going to be. It's going to be laid out horizontally, okay? And these are just the coefficients, the terms, A and B are the terms, and N is the exponent. But that's a little bit confusing when you haven't actually done the work. So let's dig in, and I can kind of give you a little bit of a guide to how to expand these using a table. I like using a table. So what I would do is I would make a little table. We'll call it coefficient. We'll have an A term. So this will be the A term, B term. And then at the end, they're going to just get multiplied, so we're going to do a product. And I might have to utilize some additional paper to work this out, and you're welcome to do the same. So first of all, we're trying to expand x plus y to the fifth power. So if you look at your Pascal's triangle, and I never did show you the completed one from the previous expansion, so you can see it's, let me just fill that out real quick. You're never really going to have to go much past the sixth or seventh line. I doubt you'll ever be this far along, but in case you are, I'll go up to here. But let's reference this triangle, and you can make this out each time. So if this is the fifth power, we want to go to the actual sixth line, 1, 2, 3, 4, 5, 6. And these are going to be our coefficients. So that means there's going to be 6 terms. So just for reference, I'm gonna keep this as a table, and the six coefficients are going to be 1, 5, 10, 10, 5, 1. Okay, that's simple enough. Now let's figure out how to expand the other terms. So we're going to start with the A term. This would be our A term. This would be our B. We're going to take, since it's a plus, we're gonna just take that A, that x, and raise it to the fifth power. Okay, that's our highest exponent. And we're going to count down x to the fourth, x to the third, x squared, x to the first, and x to the 0 power. And we'll do the same thing with the b value, the y. So it's going to be y to the 0, except we're counting up this time. Y to the first, y squared, y cubed, y to the fourth, and y to the fifth. We want our exponents to add to the exponent here, so 5. Well, anything to the 0 power, is 1, so that can cancel out. This is going to be 1 times x to the fifth, which is x to the fifth. This is going to be 5 times x to the fourth times y to the first, which is y. So 5x to the fourth y. This will be 10 times x cubed, y cubed. So 10x, x cubed, y squared. This will be 10x squared, y cubed. And this will be 5 times x times y to the fourth. And there's no x here, so it's 1 times y to the fifth, or just y to the fifth. And so your final answer will be x to the fifth plus 5x to the 4y plus 10x cubed y squared plus 10x squared y cubed plus 5xy to the fourth. And let me squeeze that y to the fifth on there. And that's what you get. If I were to multiply this by itself 5 times, you would get what I have down here. But the binomial theorem, and especially using that Pascal's triangle to get the coefficient, is a real nice time saver to help get those. Let's do one more together, and then you can try this one. So now we're going to expand 3x minus 2 to the fourth power. And again, I'm going to write coefficient A term, B term product. So I'm going to write it a little smaller. So I'll do coefficient A, B product. Again, we want to leave some room at the bottom for the answer. So This is a fourth power, which means there are going to be 5. There's going to be always one more term. 2, 3, 4. So there should be 5 rows in your table. And that coefficient this would be a 0, 1, 2, 3. This is what we want here, 1, 4, 6, 4, 1. So those are the numbers there. You won't get a table here, so you have to kind of know how to make that up. Now let's look at our A term. Our A term is 3x. Our B is a negative, so we got to be careful with that negative. So let's look at the A terms first. It's going to be 3x to the 4th power, 3x cubed, 3x squared, 3x to the 1st, which is 3x, and 3x to the 0, which is 1. So that'll cancel out. And let's do the same thing with the b's. The b's are going to be negative 2 to the 0. That's going to cancel out. Negative 2 to the 1st power, which is negative 2. Negative 2 squared, which is positive 4. Negative squared is positive. Negative 2 to the 3rd, which would be negative 2 times negative 2 times negative 2 is negative 8. And negative 2 to the 4th power is a positive. So those signs are going to alternate. So our product will be 1 times 3 to the 4th times x to the 4th. Now 3 to the 4th power is, you can use your calculator, that should give you 81, 9 times 9. So it's 81 x to the 4th. 3 to the 3rd, that's 27. So 4 times 27 times negative 2. And I kind of cheat and just kind of type them all together on the calculator. I'll do 4, 3 to the 3rd. Doesn't hurt to just check that in your calculator. That's going to give you negative 216. And so the x is going to be to the 3rd power. So negative 216 x to the 3rd power. Same thing here. It's going to be 6 times 3 squared times negative 2 squared, and then there's going to be an x squared with it. So 6, 3 squared, negative 2 squared, and that should be 4 times 9 times 6, which would give you 216, but this one's positive. So 216x squared, and 4 times 3 to the 1st, that's 12. Negative 2 to the 3rd is 8, and 12, negative 8. So 12 times negative 8 should be negative 96. And that's x to the 1st, so it's going to be x. And that's 1. Those cancel out. That's 1. So negative 2 to the 4th power is positive 16. Don't be afraid to check it in here just to double check you should be able to use a calculator on any of these type of problems. So we have our terms. Let me rewrite it out. 81 x to the 4th minus 216 x to the 3rd plus 216 x squared minus 96. Notice how the signs are alternating here. Plus 16. That's your answer. Okay, guys, I would like you to try the one with the 4x minus 5y. Pause the video and work it out and see what you get, and I'll have the answer after you've tried it. Okay, after some work here, I was able to get the answer. Double check the table and my numbers and make sure you're getting similar numbers. Again, look at since there's a minus sign in there, look at how the signs are alternating. That only applies with real numbers. So when you get to the I stuff down below, those rules kind of go away. But at least up here, these are the numbers that I'm getting. All right, the last one I want to try with you is some of these more complex ones here with the negatives and the square root. First, let's do a little refresher. Y'all know that the square root of negative 16, that's going to be 4i. So we're going to keep that in mind as we're solving it out. So also, just to refresh you guys, that I to the 1st is I squared is negative 1, I cubed is negative I to the 4th power is positive 1, and that pattern cycles over after 5. So just remember that. Hopefully you guys have done that before in a previous math class, but if not, you can use that as a guide. So to expand this, this is a third power. I'm going to go back up here and I'm going to use this 1, 3, 3, 1 since this is first, second, third. So let's get our table going. Coefficient, A, B, product. It's only going to be 4 terms. So 1, 3, 3, 1. A is going to be 7 cubed. A is 7, so 7 cubed, 7 squared, 7 to the first, 7 to the 0. That cancels out. B is actually 4i, so it's going to be 4i to the 0, which again is 1. That cancels out. 4i to the first, 4i squared, and 4i to the third power. Now remember, when you're raising stuff in parentheses to exponent, everything gets raised, including the first number. So let's look at the product. That's going to be 1 times 7 cubed. 7 to the third power is 343. So that's just 343. 3 times 7 squared, that's 49, times 3. Use your calculator, and you're going to get 147. And then you got to multiply it by 4. So that's 588, but there's an I. So 588I. Okay, bear with the announcements that are on here. This is going to be 3 times 7 times 4 squared times I squared. So 3 times 7 times 4 squared times I squared. I squared is negative 1. So that's actually going to be 3 times 7 times 4 squared times negative 1. And I'm going to go ahead and throw that right in the calculator. That's going to be negative 336. And the last one, 1 times 4 cubed times I. So it's going to be 4 cubed is 64. So 1 times 64. So 64, and then times I to the third power. Now I to the third power is negative I. You can even do that in here. You do second period, and that gets you I, and you can double check those in here, negative I. So that's going to be negative 64I. So if I'm combining terms, this is kind of different than the other ones, but I'm doing 343 plus 588I minus 336 minus 64I, and you can actually combine your like terms. You know, these are going to combine to 4, 5, 6, 7. And these two combine to, let's see, did I do that right? 64 times 1, I to the third. So that should be 588 minus 64. So 524I. All right, guys, pause the video and try that very last problem, and we'll check the answer. Okay, here this is a solution for this last example here, and just take a look at it very carefully and check your answers and let me know if you have any questions.